All right, so I'm going to quickly go through your 10-3B worksheet with you, just do a few of the, we'll do the odds, and then you guys can do the evens in the back. So we're going to get through this first column here, kind of get set up for success. So if you don't have the worksheet yet, see if we can pause and get the worksheets in your hands. So here we go, number one. For number one, we are just going to distribute. Okay, so what's tricky about 10-3B is now we're going to be multiplying but also adding. And so in 10-3A we were adding, now in 10-2 we were multiplying, doing a little combination of both, and so you have to know when to use what rule or how it works. So multiplication is a little bit more forgiving. Anybody can be multiplied. So just remember, anything can be multiplied together. In order to add, you got to have like piles of common decimals. So I cannot add a square root of 3 and a 4 root 5 because those are different piles of different decimal equivalents. Okay, but I can double them. And so remember, when I multiply by 2 here, there's really a 1 on the outside. And so I just multiply outside numbers times outside numbers and inside numbers times inside numbers. So there is no inside number. So this just becomes 2 root 3. And then I distribute that to this other radical, and again, just outside numbers because there is no radical for with the 2. So this becomes 8 root 5. Oh, we decided to go red for a hot second, and then we switch back. At this point, we have to look and ask ourselves, can I put those 2 piles together? And the answer is no. Okay, there's going to be times where we can, though, today, so that's going to get a little tricky. But 2 root 3 plus 8 root 5 is the simplest form of this. I have 2 ugly root 3 decimals. I have 8 ugly root 5 decimals. That's as simple as we can get. Go through your PDF. There's no perfects inside there. There's no denominators, and there's no fractions. That we'll save for tomorrow. All right, going on to number 3 here. So for number 3, we got root 5 on the outside. So this time not a whole number on the outside, but a radical on the outside. And then 2 radicals inside. Remember, I can't subtract a root 5 and a root 2. I can't put those together because they're different decimals, but I can multiply them. So I'm going to distribute the root 5, and now that that's a root and another root, that actually becomes root 25. It's going to be kind of crazy at first, but you'll get the hang of it. And then root 5 times negative root 2 is negative root 10. So from this stuff, we can say then that this root 25, looking for the perfect, turns into 5. I can't do anything with root 10. I look at root 10, can't do anything with it. So now we've got just a whole number 5 and an ugly decimal 10. That's as simple as this gets. Okay, number 5. When you have a binomial times another binomial, that turns into FOIL, right? So now we're going to FOIL this thing. It's going to go back to this. So for number 5, we got 2 minus 4 root 2. And we've got 2 plus 4 root 2. Now we did a bunch of these back in chapter 8, where the middle term changed signs, but the numbers were all the same, right? And these are called difference of perfect squares or conjugates. So when you FOIL these conjugates, different things happen. So let's go through and look what happens here. So we're going to do first terms, which is the 2 times 2 is 4. Outer terms is distributing that 2 to the other term in that other parenthesis. So 2 times a positive 4 root 2 is a positive 8 root 2. And now we're moving on to the inner term. So that's moving to the negative 4 root 2, and the positive 2 makes negative 8 root 2. And then negative 4 root 2 and a positive 4 root 2, the positive and the negative makes negative. The 4 and 4 makes 16, and the root 2 makes root 4. And that was the first time where we multiplied where we had inside and outside. So we've had just outside, just inside, inside, outside, inside, outside. And here we go. So let's look at our perfect, see if there's anything that can simplify. I do see that root 4 right here could be root 2, or I'm sorry, just 2, right? Root 4 turns into 2, and so this negative 16 And that 2 makes a negative 32. So that actually ends up being a whole number. These other two in the middle, I got a positive 8 root 2 and a negative 8 root 2. That becomes 0 root 2s. So they just cancel each other out. They're opposites of each other. And so this 4 out front and this negative 32 can be put together and our nice little answer of negative 28. So number 5, all of the radicals just completely disappear. Okay, in number 7, this is what we've done all along. When we see something squared, we just simply break it apart into 2. So I want you to cross off that squared and write 2 minus 2 root 5 again, right next to this one. So it said squared. Well, squared just means multiply by itself. So expand it out, and then we're going to FOIL. Okay, so when we FOIL this one, we're going to do first, 2 times 2 is 4. Outer, 2 times negative 2 root 5 is negative 4 root 5. Remember, outside numbers with outside numbers. The inner 2 terms is a negative 2 root 5 and a positive 2. That makes another negative 4 root 5. So they're not opposites this time. They're exactly the same. That's what happens when we square. And then the last term, remember, this is a negative, right? Negative 2 root 5 and another negative 2 root 5 makes a positive 4 root 25. So slow down, take it slow. I notice that root 25 can become a 5, and then that 4 and 5 make 20. And these are not going to cancel out this time, but they're going to be put together. I have 4 different numbers going on here. I have a 4, a negative root 4 root 5, another negative 4 root 5, and a 20. I can put these into 2 piles. I can pile up the 4 and the 20, making them 24, combined like terms. And then I've got a negative 4 root 5 and another negative 4 root 5. I actually have negative 8 root 5s. Remember, you're saying how many of the ugly root 5 we have. That's as simple as you can get. All right, moving on to number 9, just going back to distributing a little easier again. It mixes it up, keeps you on your toes. Root 8 distributed through root 2 plus 5 root 8. Okay, so when we do this, root 8 and root 2, they're both inside, root 16. Root 8, remember there's a 1 out in front. If it helps, put it there. 1 times 5 is 5, and then root 8 is 64. Write it down, let your brain see it. We know, though, that the root 64 is going to turn into 8, and the 8 and 5 make 40. And this root 16 becomes a 4. And so I wasn't anticipating this, but this crazy mess of multiplying all those radicals turns into 44. It just turns into a nice whole number 44. And the last one is just another FOIL. We'll just practice that one more time where you have to break them apart or write it down twice. Root 3 plus root 6. When it says squared, we're just going to write it a second time. So cross off the squared, rewrite it a second time, and we're going to FOIL. Root 3 times root 3 is root 9. That's our first. Our outer, root 3 times root 6 is root 18. Inner, root 6 plus root 3 is another root 18. And a root 6 and a root 6 makes a root 36. Now it's time to clean up. So when we do our cleanup, root 9 is perfect of 3. I have 1 root 18 here, a 1 root 18 here, and I have a root 36 becomes 6, right? So I can put these two together. I also notice those are 18. So not only do they need to be put together in the same pile, we also need to take out a perfect. It doesn't matter what order you do that in. I'm going to put them together first. So I have a 3 here and I have a 6 here. That makes 9. I like to put the whole number out in front. That's typical what we do. And then we have 2 root 18s. We're not quite done yet. We have 1 pile of root 18s, but root 18 can be simplified. Root 18 turns into root 9 and root 2. Don't forget the roots. Root 9 becomes 3. The 2 and 3 make 6, not 5. And so 9 plus 6 root 2 is the simplest form of that problem. Okay? Good luck. Slow down. Take your time with it. Don't forget there's a back. Do at the end of the hour. No exceptions to that. Good luck.